Okay, this is a follow-up to the first video. We sort of introduced the stoichiometry, and this is going to look at a couple of things. We're going to look at problems that are actually a little easier. We're going to look at the mole to mole real quick just to talk about that. I skipped that initially because I wanted to look at the three-step problems. We're going to talk about that here in a minute. And we went through this three-step problem, but I'm going to erase that. And then we're going to go up here and we're going to talk about how we do moles to moles. Okay, so I cleaned that up, and we're just going to look real quickly at mole to mole. Now, this is not near as common, and basically what happens here is you can eliminate steps if you start in moles or end in moles. So if you think about it, I was saying that you have three conversions on a lot of these, very common to have three conversion factors. This middle step here, you're always going to need that step. That's the mole ratio. So the mole ratio is the question mark over what you have, and that step you're always going to have that. But this first step and last step, well, this first step is to get into moles, so it kind of looks like that. And the last step is to get rid of moles, and it kind of looks like that. But, well, what if they ask you a question like this that says, well, how many moles do I have if I have 2.3 moles of a chemical? Well, if we're going to go from moles to moles, you don't need the first step or the third step. So if I start in moles, I don't need to convert to moles. If I end in moles, I don't need to convert out of moles. And so if you see the word mole once, you can get rid of a step. If you see the word mole twice, you can remove two steps. So if you start in moles, get rid of the first step. If you end in moles, you can get rid of the last step. So let's just look at one of these real quick and show how straightforward they can be. So if you look at number 2, it says how many moles, okay, so I'm looking for an answer in moles. There goes step 3. Am I going to get of hydrochloric acid? So we're going to go over your hydrochloric acid, and we're going to put a question mark there. Going to put a question mark, a better question mark, hopefully. Put a question mark over the hydrochloric acid, and that's going to be moles. Start with 2.3 moles of zinc, so I can put the 2.3 moles right there by zinc, and then these chemicals are not going to end up being used. Now, we still need to balance. We still need to do those things, and so let's balance, because that is always going to be important, the balancing piece. Let's balance real quick. So it looks like we need a 2 in front of the HCl, and that takes care of the chlorine and the hydrogen and zinc. So there we go. 2, 1, 1, 1. So how would I set this up? I would go 2.3 moles of zinc. That does not change. You always write down the number, the unit, and the chemical. I'm going to skip the first step because I already have moles. So again, I have moles, and so I do not need to convert into them. I'm going to go into the mole ratio. That's the new thing. Have to have that. That is what we talked about up here. What do you have, and what are you looking for? So I'm looking for the question mark, and what I have is what I start with. So let's go ahead and try to find the question mark. And oh, it's right here. I'm looking for moles of hydrochloric acid, so I can put 2 moles of HCl on top. And so again, where are we getting those numbers? Where did this 2 come from? It came from right here. It's the coefficient, it's the number in front, so that's where we get the 2 moles of hydrochloric acid. That's what I'm looking for. What did I already have? Well, I had this zinc right here, and there's nothing in front of the zinc, so that's a 1. And since I don't have to convert into something different, it wants moles, I can be completed. I can solve this in one step. If you look at your units, moles have canceled, zinc canceled. You're left with moles of hydrochloric acid, which is what they wanted. So 2.3 times 2 divided by 1, 2.3 times 2 is 4.6, and that's how we get that answer. Now, this is very uncommon, and so again, I wouldn't spend a lot of time with this because it's easy, but normally we do problems a little bit more, with a little bit more going on. So let's slide down here and let's look at one of these liter ones here, like number 5. So let's look at number 5 real quick. So let's start number 5 by figuring out what information is important. So how many liters of oxygen gas? So I'm reading the problem and it says right here how many liters of oxygen gas. That is important because that's what they want us to find. So we're going to go down here above oxygen. I'm going to put a question mark and I'm going to put an L for liters. Would result from the decomposition of, none of that matters. I'm going to go right to the number, and 30.65 matters, and it's potassium chlorate. That matters. So those pieces of information are important. Again, I find the number. There's only one number, and then the chemical that's after that. And then I'm going to go ahead and plug that in on top. So a lot of times people get this problem incorrect because they just get the wrong chemical. So 30.65 grams is going to go there. And the reason people get this wrong is they get the two chemicals confused. So let me slide this in here a little bit better. 30.65 grams. Okay, so that's the potassium chlorate, and this is potassium chloride. So they're looking for this first one. This potassium chloride is going to get an X because we're not going to do anything with it. Now you do need to balance the problem. So let's go ahead and balance it real quick. And the way this one works is if you put a 2 here and a 2 there, you're going to have 2 potassiums on both sides, 2 chlorines on both sides, and then you've got 2 times 3 is 6 O's, so we'll need to slide a 3 right there. All right, so again, it's going to have 3 steps. So it's going to look like this. You're going to have a conversion factor, conversion factor, conversion factor. Now the middle one is going to be the question mark on top over what you have on the bottom. So that's going to be the middle step, the mole ratio. So again, that's the new thing when we're talking about what's happening here, and we're talking about something that's we haven't done before. Then the mole ratio is really the only new process. Everything else is just variations of things that we've already done, converted to moles, converted to liters, etc. So you're going to see that here. So let's run this through real quick, and I'm going to start with 30 point. Actually, I think I'm going to slide it down here, get a little more space. So we're going to slide this down here. We're going to do it at the bottom here. So I know it's not number 6, it's number 5, but I'm going to use this space down here. So we're going to go 30.65 grams of KClO3. All right, so again, what am I writing down? I'm writing down the number, the unit, and the chemical. Those are all important. So let's do our first conversion factor. We want to convert into moles because we do not have moles. These do not work if you don't have moles. So we're going to go 1 mole on top, and then we're going to add up the KClO3 from the periodic table. All right, so we're going to add that up. Okay, so 122.54. You've done that a bunch. You can look that up on the periodic table and add them up. So I'm not showing you the math on that, but it's just your 3 oxygens plus your chlorine plus your potassium. Look them up, add them up, and you get the 122.54. Okay, new step. The new step is the mole ratio, and so that's going to be what I'm looking for, or my question mark. And if we kind of look here at the top again, question mark is on top, what I have is on bottom, and we're talking about the numbers in front. Okay, so we're talking about these coefficients. So remember, we're doing number 5 here. So we're looking at these 2s and that 3. So I'm looking for the question mark, which is the oxygen. So that's why we wrote this down on top, is so that we had a plan. Our plan is to find the oxygen. So that's going to be 3 because of the coefficient. That's the number we used in front to balance. Moles of O2. And right here, That's what we started with. That's the number. That's what we have. So it's going to be 2 moles KClO3. And then we're going to turn it into whatever unit they want. And so in this particular problem, they wanted liters right there. So they wanted liters. So that makes this problem a little bit more straightforward because liters are pretty easy. You don't have to look up a lot. So remember they said standard temperature and pressure. They're saying, hey, might want to use 22.4 because that's kind of the hint. So down here, this should say 22.4 liters for every 1 mole. Now I kind of ran out of space there, so this is the end of the problem. So you would plug in your equals sign, and then you would go ahead and run through your calculator. So how do we run it through the calculator? You're going to run through like this. You're going to do 30.65. You're going to enter that into your calculator first. And then you're going to divide by 1 and 22.54 times 3 divided by 2 times 22.4. All right, so I went ahead and wrote that out, erased the top and wrote that out for you. So again, we always start with the number that they gave you that goes into the display of your calculator. Then we're dividing because this is on the bottom, so we divide by 122.54. I think it's a good idea to kind of hit enter then, so kind of hit enter here. Then this is interesting because you actually have a number on top and a number on the bottom, numerator and denominator, that are not ones. And so what I did is I multiplied by 3 because it's on top. I then divided by 2 because that was on the bottom. So you actually used both multiplication and division here. And then at the end, I am going to multiply by 22.4 because that is at the end. Again, sometimes students make mistakes when they put too much information inside the calculator at once. And so for me, I hit enter or equals at every operation. So for me, it'd be 30.65 divided by 122.54, enter, times 3, enter, divided by 2, enter, and then times 22.4, enter. Now, that does not mean that you have to do it that way. It's just I'm trying to get you to avoid mistakes. And then there you go. There's the 8.4 liters. Now, if we do one last thing, make sure to check our units. Make sure that they did cancel, because if they don't, we made a mistake. If you look, we've got grams on top, grams on bottom. Okay, that's good. They canceled. KClO3 is on top and bottom. It canceled. There's a mole, top and bottom. That canceled. And then a mole, top and bottom, canceled. So what do we have left? We have left what they wanted us to find. We have oxygen here, and we have liters right there. And so that means that I set it up correctly. So remember, we're canceling units, things like grams, we're canceling chemicals, we're canceling moles, but we're not canceling the numbers, we're just getting rid of units so that at the end we get what they wanted, which was they were looking for liters of oxygen gas. So they were looking for this, and that is what we end up finding. So we know that unless we got a molar mass wrong or we made a calculator mistake, this should be the correct answer. So I have run through one of each type. The three-step problems are very common. So what you should do is work through these. So we did 3 and then we did 5. So you should try to do 4. See if you can get that answer. Remember, the answer is right there. And then you should also work on 6. Again, the answer is right here. So, all right. Hopefully do well and ask questions of me if you're having some difficulty.